So let's look at this ceiling here, which is very, very effective to render out in real time very exquisitely small amounts of detail. So this mesh in reality is extremely high poly. It's got, I think when I saved it out as a mesh, it was about 700 megabytes here, and it's taking ages to save. And I thought Max was crashing on me there just a minute. So it not only it's very, very heavy in Polygon, but also this was also generated with RelClone, and you will see that there is a huge amount of intersecting geometry in when RelClone does all these this mesh. You see that it's a real mess. So the way, I'm not going to go into how this was done in RelClone. It was pretty simple. You know, I just very quickly, I just took a segment like this and basically used RelClone to generate it over a line, a spline that was traced around the center of this. But it's the kind of thing that would be practically, that would just bring the scene down to its knees, I think, in terms of polygons. Yeah, it's, what is it? 11 million polygons. So this would be a big no-no. We couldn't have that into a real-time scene. So how do we create the parallax material for that? So I'll take you through the parallax, and then we'll come back into Max to generate the texture that we need to. So let's have a look at the material. Okay, I've got a few scalar parameters here in the instance material that I'm going to go through in a minute. But here, again, a very extremely simple material is just near white for the base color. And then we've got this parallax occlusion mapping, and then a texture for the ambient occlusion. So really nothing too complicated on the shader front. The big thing obviously being this parallax occlusion mapping node. And again, the defaults here are all pretty good as they are. I've set up all these scalar parameters, so by just pressing S and click, you get a scalar parameter which allows you to go back into the instance material and change the values. So that's great. So we can see what that does in the interface. So I'll let you just copy these, and then all I did is just put the scalar parameter and put the default value here into the value that's suggested. Actually, here I put 0.05, but near enough. See 8 here, and the steps I've put that to 64. Well, here there are 32. But the idea is that we can tweak them in the interface and see what that does. Then the texture coordinate, really simple. I've just plugged that in here. And the height map channel, I've just put a color here and just value of 1 on the red. Basically, this gives you which channel this is. And oh yeah, before I forget, this is a texture object. So the way you just do, I just did a texture object. I'll just import any image in here, and then you just right click and say convert to texture object. So that's very easy. And then again, another parameter for the reference plane. Okay, so here for value, default value 1, and I put it says default value of 1, I put default value of 2 in here. So you see all the default values that I've put in here. And then when the parallax comes out, I've put it at a into a texture sample, which is plugged into the normal. And the texture sample needs to be a sampler type normal here, just so that it makes sense when you plug it into the normal plug. And then we've got the ambient occlusion here, just a simple image rendered out as a ambient occlusion like this. Okay, so that's pretty simple. So you will see that the big thing is, how do we get this texture? So this has to be a specific type of texture, which is called a height map. And what that is, it's basically like a bump map. But the point about this is that all the points which will be far away will be dark, and the closest point will be white. So you can see here, even on the very, very small height difference between this point and that point, there's a slight gradient, and there's definitely a gradient from the height here to here. So that's a way to really bring in an incredible amount of detail if you've got this piece of geometry. The other one that we will need to generate is the ambient occlusion, and that's again used here. I used a V-Ray dirt material. So let's jump into Max, and I'll just show you quickly how to do that. So here we are in Max. What I've done, so first thing I've done is that I've isolated my ceiling into, because obviously it's very, very high poly, so it's difficult to work with it as a mesh. And I have collapsed it as a mesh because my rail clone object was not working properly. So that's why it's quite difficult. Normally you would sort of work with V-Ray proxies or rail clone, things like that, for things this heavy. Anyway, so I've applied a planar UV map that was rotated 90 degrees like this, so, and would just fit exactly the height of the object. So you can see that it's just touching the top and bottom, and then I applied this gradient material into the self-illumination slot. So if that's what that wants to show up, we can see that it's going to have the black at the bottom and the white at the top. So that's exactly what we want. So if I render this out, I'll just render a zoomed in view of it. Takes a little bit of time, and here we go. And that's exactly the image that we want. So make sure that there's no other kind of information. That's why I've isolated the geometry. And so that's just rendered out as a square image and imported into Unreal. Now for the ambient occlusion, that's again super simple, super simple. I've added a V-Ray dirt with a very small radius, and that also gives us the result that we want. So here we go. And although that's not showing quite as maybe as much as I would have liked in the Unreal scene, I'm sure that can be further improved, but it's just giving us a really good result. The thing about the occlusion mapping to notice is that, you know, if here it really looks 3D, so it's occluding what's behind. I don't know if we can see very well, but if I go right, you can see that it's just a plane. So there's all this funny stuff happening when you get very, very close. But from far, it really looks 3D, much superior than a normal map. So let's just go back quickly into the instance material where I've been able to expose my parameters. And so the depth here, you know, you can see how that's just doing some funny things to our eyes, but it's really useful to be able to play, you know, in the interface with these values. So, you know, this kind of very small value here was appropriate, but it might be completely different in your project. So we've just got sort of 0.1 here, 0.01. The max steps, that's just sort of giving if I put these really low, when we get close, we'll sort of see through you see, it sort of reduces the kind of the resolution. And so again, I've just sort of kept that quite high, 128, and again, these are values that will give you the different resolution. So here it says downward. I can't actually quite see what difference it makes in this case, but I'll just left it on the default value. And then the ref plane is quite difficult to kind of understand exactly what it does, but it gives the bottom level of the mesh effectively. So if I remember, it was on 0.08. I'll just redo that. It was a 0.08. So you'll see that when I tweak that, I'm looking at the edge here. It's not giving us the effect that we want. So I just need to make sure it's all properly aligned on the edges where we want it. It gives us kind of the reference of depth. And of course, the UV mapping, the UV map is just a very simple plane that matches the edges of, so it needs to match perfectly where the ceiling is going to be. So there you go. That's pretty simple in reality. Being as long as you've got your height map, you're pretty good to go. And I'm really impressed by what this technique can do when we need to portray very high detail, where really the normal map is not going to be enough here. We really needed to make this a lot more 3D.